Hey everybody, my name's Rich Kenny. I'm the Global IT Director at Techbuyer, and welcome to our Remain Day webinar. So Techbuyer recently joined the Remanufacturing Industries Council. It's great to take part. We're looking forward to sharing some information on how remanufacturing applies to IT and how this differs from mechanical remanufacturing. So we find a lot of the public perception is that IT hardware degrades over time, and so you see a performance decrease of remanufactured against original products. The University of East London recently carried out research that proves remanufactured servers perform identically to new, and in fact that the immediate previous generation can outperform the latest if it's configured correctly. So joining me on this presentation, this webinar, is Nora Teal. She's the research associate from the University of East London.
Hi everyone.
So before we start with the research, I'm going to explain a little bit about our remanufacturing process, which is covered on this slide. So Techbuyer is a global expert in the buying, refurbishment and selling of enterprise IT, mostly servers, storage and networking for the data center environment, what we'd class as enterprise spares. A lot of our business is focused on bringing in redundant IT from a variety of sources. We execute a 25-point testing program on servers, data sanitization where necessary, and everything is restored to an as-new condition to be sold as spares and upgrades. We also have a remanufacturing portion of the business, which rebuilds fully configured servers, which is dealt with a client according to individual client needs from the component parts and installs relevant software. Everything gets issued a 3-year warranty on all our products. Anything we can't use goes to recycling, but everyone in the business has a genuine hatred of waste. That's company-wide. If we can reuse or repair, we do that as a preference every single time. Our technical staff repair components wherever possible, and our expertise on this is growing, so from sort of memory and tape drives and all sorts of things. I would say our customers care less about that, though, than the economic benefits of remanufacture. So we had a paper written by a postgrad at one of our local business schools that said that customers buy from us because of cost and performance rather than the environmental considerations. The standard argument against using remanufactured equipment in the data center is that new equipment is more energy efficient. Since the IT load accounts for the biggest proportion of energy use in the sector, it's important for customers to consider that. In the past, new servers significantly increased the amount of compute power per watt, so the advice was generally to refresh often and to refresh with new because there was significant benefits on the latest generation. However, as time's gone on, newer generations are making less of an improvement on older models. This is for a variety of reasons, and this is what our study with the University of East London was designed to explore. So I'll hand over to Nor now to take you through it.
Thanks, Rich. So a server is in many ways a large computer. If you open one up, you will see a motherboard, CPUs, which are behind the heatsinks in this picture, memory, storage, transistors, and fans to keep everything from overheating. If we strip this down to essential components, we have the CPU, which gives the processing power, memory, which provides short-term access to data, and storage, which you can think of as the server's filing cabinet. These are the components we concentrated on during our experiments. When most people think of the compute power of a server, they think the CPU is the workhorse. It is generally front and center of all discussion around compute performance. However, there are two helpers in this function, storage and memory, that can be very impactful. If you add more storage or more memory, you can upgrade the machine. We are about to show you what that looks like. A big part of the study was understanding server trends over time. A study was conducted by Uptime Institute, which analyzes performance data for hundreds of servers between 2007 and 2019. The graph displays how CPU technology evolved over time, along with performance and idle power consumption. The figure reveals interesting insights. During the beginning of the decade, the move from one CPU lithography to another, for example 65 nanometers to 49 nanometers, presented major performance per watts gains, represented in the orange line, as well as substantial reduction in idle power, shown in the blue line. However, over the past few years, while lithography was fixed at 14 nanometers, the increase in performance per watt has been escorted by a steady increase in idle power consumption, perhaps due to the increase in core count to achieve performance gains. This is one reason why the case for hardware refresh for more recent kit has become weaker, especially that servers in real-life deployments tend to spend 75% of their time, on average, in idle mode. As such, the increase in idle power may offset energy gains from performance. It was of great interest for us to study the performance gain between latest server generation and an older generation released after 2015. We expected the gain to be minimal due to the server trend discussed above. Therefore, remanufacturing machines from a previous generation could be a good answer for energy efficiency as well as saving on the vital precious metals and critical raw materials that IT hardware contains. The first stage was to verify that a new and refurbished server against the same make and model have the same level of performance. This is done by measuring energy draw and performance, measured as number of operations done per second, of the CPU, storage, memory, as well as the overall score. We then tested different combinations of new and refurbished. For example, new machines with refurbished components and refurbished machines with new components. Our results showed that there was no real difference between the two.
For us, this was not a surprise, given that the lifespan on servers is much longer than 3 years. However, it was good to have this verified by university. To the best of our knowledge, this is the first time this type of research had actually ever been done. We really wanted to know what would happen when an older server was upgraded with additional capacity. We wanted to see if it could outperform the latest generation. That was covered by the next stage of testing.
The showcase comparison is between an HPE ProLiant DL380 Gen 9, which was released in Q4 in 2014, and an HPE ProLiant DL380 Gen 10, released in Q4 in 2017. These were chosen since they are very popular servers, but we plan to expand on this testing for more makes and models. We ran the same set of tests as we did for comparing new and refurbished energy efficiency, but this time varied the components in the older Generation 9 model. We found that a Generation 9 with E5v3 and E5v4 dual CPUs outperformed a Generation 10 model with base configuration using dual Skylake Silver CPUs, just by adding more RAM. The results verified that the performance gain between latest generation and previous one was in fact very little, as discussed earlier on. We'd like to add though that this would have not been the case for servers released prior to mid-2014, because server performance jumped significantly afterwards. But we do expect this to be the case for the next few years until a breakthrough in CPU technology takes place.
Now, these tests were part of a longer-term project where we'll be building a data center energy efficiency modeling tool to provide you with scientific recommendations to improve your overall data center efficiency, primarily by improving server hardware configuration. However, what is most interesting here is that we've been able to get the immediate previous generation to outperform the latest model. That's what's demonstrated on this slide at the moment. For a long time, data industry believed that you absolutely had to refresh with the new and latest in order to achieve maximum efficiency. What this proves is that in certain environments, remanufactured machines could be the better choice for cost, performance, and energy draw. As I mentioned at the beginning of the presentation, cost and performance are obviously really important to many organisations. Most people, though, care about the bigger picture of cutting waste and pollution as well as protecting our natural resources. The exact size of the environmental impact is under debate at the moment. Different experts will tell you different things. We've tried to keep this slide in line with this. We do know that both waste and energy usage is on a steep upwards curve for the data center industry. So resource and waste, energy use, air emissions are all increasing. So this is the latest information that we have on what it costs us to make a new server. It's from a Deloitte report in 2015, which informed the EU Eco-Design Directive. So it's kind of the best information available at the time. Techbuyer is currently involved with a multinational research project called SERT, which will update and improve on this information. The likelihood is that modern servers have a higher carbon footprint and water usage than these statistics suggest, but as you can see on the slide here, there's quite a lot of notable materials and energy gone into the actual production of servers. The macro picture on this is that humanity is spending way over its limit in terms of its use of natural resources and also what the Earth can recover from. By 2050, this overspend will be 3 times the amount the planet can provide. That's unless we change how we do things. This kind of slide talks about the ways we can make best use of resources, but the order is important too. So if we maintain our assets for as long as possible, we use 100% of the materials and use minimum additional energy. Refurbishment, which is restoring goods to factory condition, and reuse, which is building them into new machines, is our next best option. In our sector, this is what remanufacturing means. There are limits to which components go with which, so remanufacturing servers means sticking within the confines of each generation, but we can increase performance within these parameters. The last and final option is to recycle, especially with ICT. This is because many of the materials exist in trace amounts and not all of them are recoverable, so you'll never get 100% return rate. Also, with recovering the materials, you have an additional energy cost which you want to avoid if you can. This kind of thinking comes under heading circular economy now, although the remanufacturing industry existed long before the term was invented. Those that support the circular economy in the data center industry point to the Google model to show that it can be economically as well as environmentally successful. So, looking at the slide, some of the key points on this one is that they've kind of been refurbishing their own since 2015, which is a long time. They don't just make a distinction between refurbished and new inventory. Both are considered equivalent, so they both sit on the shelf and they're not separately labelled. And that it saved Google about $1 billion in operations through energy efficiency alone by kind of refurbishing its own computing infrastructure. Now Google's able to do this because it manufactures its own servers and can control the outgoing and return supply chain. So what companies like we do is provide smaller organisations with the capacity to do the exact same thing by effectively working as one of their service arms. It's a little different financially because we buy equipment in and then resell, but this works well for our customers because they don't have the overhead. They're also probably not big enough to do it on a rolling basis, so they get the benefit of specialist remanufacture perfected over many years, even if they only use it once. So, we know that the remanufactured servers perform as well as new, and that it's possible to get the immediate past generation to outgun the latest generation with the correct component level upgrades. So what does that mean for remanufacturing as a whole? We believe it means taking a different approach to IT remanufacturing rather than mechanical remanufacturing. For IT, we can take customers through a decision tree where questions like these are asked on the slide. There is no wear and tear for IT in the same way that there is for mechanical components. In fact, previous models can outperform newer models with the right component upgrades. And you need to think about what you're buying, what it's going to be used for, and where it's going. Is this going to be production? Is it going to be test? Is it going to be dev? Is it a new SAN? Look at ways you can prolong the life of existing equipment by using upgrades of components rather than complete refreshing. And also look at the cost saved and what you could buy by saving that. So this could be security software, critical infrastructure. It could be off-site backup solutions. There's lots of stuff you could be spending the money on better than spending it on new kit that you don't need. So I guess, what's the point of all this? Well, mostly that it makes sense. And if you have a product that costs less, performs just as well, and is good for the environment, why would you not choose it? So that's the end of the presentation. Thank you very much for joining us today. If you have any questions, then feel free to get in touch via the contact form or the details available on screen. Thanks again. Bye now.